Welcome back. In this video, we're going to look a little bit deeper into this idea of change in momentum, or delta P. When it comes to a change in momentum for any given object, one of the things that you want to keep in mind is that for a given object, we're not going to change the object's mass in order to change its momentum. Typically, a change in momentum will come from an object's change in velocity. Well, I want you to think about what that is, right? For the last how many months we've been in school, we've been dealing with change in velocity, right? And we know that a change in velocity is called an acceleration. And here's what I want you to ask yourself. What causes acceleration? Right? Where does an acceleration originate from? We get acceleration when we have a net force acting on an object. Right? So a net force causes an acceleration. The other thing I want you to ask yourself is, what about that force can determine an object's change in velocity or an object's acceleration? Well, the size of the force would be one of them, right? How big the force is that's acting on it. And the other thing that's going to determine how much an object changes its velocity is the amount of time that the force is acting on an object. The longer I exert a force for, the more change in velocity I'm going to get. What's funny about this is not something that most people need physics to understand. Right? That if I exert a force for a longer amount of time, I'm going to get a larger change in velocity. Well, what that tells me then is that I'm also going to get a larger change in velocity. This force times time idea is called the impulse, to where F is just the amount of force, T is the amount of time that the force acts for, and I is what we call impulse. Impulse is just change in momentum. In fact, this is known as the impulse momentum theorem. Okay, those of you that are in my class, you've probably heard me talk about how physicists are not the most creative of people. And saying that the impulse is equal to the change in momentum is the impulse momentum theorem. That's it. That's the whole thing, right? Impulse is equal to the change in momentum. That is the impulse momentum theorem. Now, there are some key things that we want to talk about when we're dealing with forces and what's going to happen. Right? We're going to have forces that are going to cause us to gain momentum. We have forces that are going to cause us to lose momentum. Right? Remember, the amount of momentum we have is based on two things: how much mass an object has and the velocity that it has. Right? The more mass, the more momentum. The more velocity, the more momentum. So there's two types of forces that can act on us. We've got a force that acts with the velocity. Oops. Right? And that's going to cause us to speed up or gain momentum, or we have forces that act against our velocity, and that's going to cause us to slow down or lose momentum. These forces are called resistive forces. And that's because they resist the motion of an object. It doesn't have to be friction. Friction would be a resistive force, but it doesn't have to be. It could be any force that's trying to slow down an object, right? That's going to be known as a resistive force in this case. Now, going back to that whole impulse momentum theorem, we know that impulse, let me give a different color here so it kind of changes things up here. Impulse is equal to change in momentum. Well, impulse is also equal to force times time. Change in momentum is also equal to PF minus PI. Well, what I want you to keep in mind is what this long equation tells us is that I can solve for anything that we see here if I'm able to use any of the others. Right? Typically, you'll hear impulse and they'll do and say force times time, and they'll do change in momentum and do PF minus PI. However, what this equation tells me is that I can also do impulse as PF minus PI. I can also do change in momentum as FT. We can add to this. What's PF and PI? That's just what? MVF minus MVI, which is also equal to MVF minus VI. Right? Any one of these can be solved for using any of the other ones. All I need is any variables in any of the sections. Right? As long as I can fill in any part of this equation, I can solve for any other part of it. Where people get themselves into trouble is they hear impulse and automatically want to do force times time. People hear change in momentum and automatically want to do PF minus PI, even when they were given a force and a time, right? I can use force and time to find change in momentum. I can use impulse to find, I can use F and T to find change in momentum. I can use PF and PI to find impulse. What you find with these problems is that there are lots of different ways to go about them. And the AP exam and even the tests or quizzes that you'll take with us love to mix in anything that you see here. Right? We might give you two velocities and a mass and ask you to find the impulse. We might give you a force and a time and ask you to find the change in momentum. And that's because they're all the same thing. All right, that's the end of this one. Thank you very much. Good luck.